Start the meeting then. All right, let's go ahead and start the meeting for Facilities Committee meeting today, October 3rd at 2 p.m. And let's go ahead and take, I guess, roll call first.
All right, Directors Fardonish
Here.
and Logan.
Present.
Great. And then we also have General Manager Jeff Brills. And then we have Waste. I guess
Utilities
Utilities
manager.
Manager.
Yeah.
Justin. And all right, good. And also Carrie is here with us to take down notes. All right. Let's go ahead. The first item is the tour of the treatment plant operations.
So what we'd like to do is we'll just do because you've been through it a few times before. We'll just kind of just to remind you, we're going to just take the same path that the water takes. We did want to stop by and show you the new C train that we put in for record storage. Justin's promised some recent upgrades are ready to go. Although we got to get the stuff out here so we can free up some space. And then we'll end at the conclusion of the treatment plant. We're gonna walk down to the Dynasand filter site and take a look at the filter. And then so those items 1 and 2 will be out and about, and then we'll come back here. For the last couple of items.
Okay, sounds good. All right, let's go ahead and get started.
Okay. She was asking if we had a golf cart.
Are we still being recorded right now?
We are.
Oh, okay.
Yeah. All right. As a reminder, we're being recorded.
Okay. And you know, Jeff, that C train, both these C trains are keyed to a key I don't have. But we can open up the back of it and take a look. We can go right through this way. We can go, I'm sorry. Yeah, we can go right down this way. We added some recent testing equipment for total
you want to show them that
suspended
too?
solids. And if you wouldn't mind just taking a quick look at that. For a pond system, total suspended solids are crucial constituent to gain understanding in. Please go ahead. Right this way. Please, right this way. Right.
After you.
Okay. So we're kind of coming in here and cleaning stuff and then getting set up to run. TSS is very straightforward where you have and there's actually 3 samples we're running right now we have inside of the oven. But you run with this flask and a funnel, you run the vacuum. Your sample is poured through a filter. And then what's left behind are those solids. You weigh the disc before you run the sample. Mm-hmm. You run it afterwards. And after it spends at least an hour at 219.2 degrees Fahrenheit inside of the oven there. Mm-hmm. And so the difference between the two is your total suspended solids. So it's a very straightforward testing, but it allows us
This is going to be
some
really,
checks and balances
really
on the
because
pond system.
You know, the testing through the lab's expensive, and so we were kind of trying to just do what was required, testing wise to cut costs, but particularly as this filter project came about, there was a need to have daily or more often tests, and rather than invest in having the lab run all those tests and then wait a week for results, Justin figured out a way to kind of make it that pay for this equipment just during this testing period.
Wow.
And so now we have the ability to run tests as often as we want. It's just our manpower. There's no other. I mean, there's probably some real minimal supply costs or something. That's about it, right? There's a little paper.
Yeah. Yes, that's right. BOD and TSS are like the two major constituents that we're tracking through in the pond system. So this helps us greatly. We were with FGL seeing up to like a month lead time and getting those results recently. And a month later, we were trying to keep track of what we did a month ago, you know. And this is so much more helpful to have in kind of real time.
So you get the results daily.
Instantly, yeah.
A couple hours.
An hour, yeah, basically an hour inside the oven, and we're good to go.
So this room is already here. This equipment's new.
Yeah.
Nice. And once you get those results, where do you track them? I'm looking at the yellow notepad.
We're transfer. So everything is going to be documented electronically.
Okay.
All of our kind
So
of
you can graph
handwritten
it?
form. Yes, everything's going to be stored electronically. It's just, you know, it's steps. We'll get there. Everything's, so we'll have databases where all
So you have to create
facilities,
those,
yes, everything's kind of
databases
from
and those
scratch. Yeah,
spreadsheets.
yeah.
Okay.
Justin, what is this here?
Yeah, so that's our flow meter. This is a Hawk data logger, and so this is connected to an ultrasonic flow meter in a partial flume. When we get out there past the headworks, we'll just point at it. We'll just look at it. It's a partial flume. It measures. It's a way to be able to measure flow, and the ultrasonic sensor is right on top, and so it's reading all that flow running underneath it, kind of just by how deep or how shallow that channel is. So, but we'll take a look at that. That's our influent meter.
And then, Justin, as we walk, I guess we also got, so we got approved to get 2 portable samplers. Remember one, and then the prices went way up, so we got another one. But then you also got a sampler through kind of as a grant, or not really a grant, but I guess it was a donated item through,
through WEF to small water
Yeah, so
purveyors.
that's going to be here permanently?
Yeah, so the idea is somewhere around where we're standing right now,
Yeah.
we're going to install this. It takes 110, so it's not a portable 12-volt situation. So it's a permanently installed, and we have conduits going out to the headworks. So we'll have hose running out there, and so we can run composite samples that are refrigerated. The sampler we got is very expensive. It's not portable; it's stationary, but it's refrigerated. The whole thing is,
unit?
you plug it in, and the whole it takes care of your sample without any kind of ice or anything along those lines. So it's a very expensive sampler. WEF was doing the Water Environmental Federation was doing. If you had interest and you participated, gave them all of your information, you were a part of many people that wanted their hands on these units, and we were lucky enough to be gifted one of these units.
Do you know when that'll be in service?
I have it in the shop. It's just there's so many things going on right now. It's just very soon.
Okay.
The next 2 to 3 months, that's going to be online, and we do have our 2 portable units now too. So those will also be in the collection system, gathering samples at lift stations and other various.
Nice.
Yeah.
Wow.
So what does that do in terms of improving your sampling, in terms of does it reduce staffing and staff effort? labor?
There's a couple of things. One is some things you cannot gain insight in a wastewater treatment plant unless you have a composite sample, not a grab sample. So up to date, the majority of our data was in grab sample, and the some of the items that we had used composite samplers, and I can show you them, but the composite samplers that we had purchased, they don't preserve the sample. They weren't it's just that they were refrigerated. There was no means to be able to pack ice. They were very small, and so in summertime here, when it's the ambient temperature is the BOD can. TSS is not so vulnerable, but BOD is incredibly vulnerable to temperature changes, and so this will help us be able to collect kind of reliable,
More
consistent,
accurate,
and gain insight into some of the constituents that really have to be obtained through a composite sampler. So anyways, this.
I don't think it's something that we're going to have in use daily or something, but
No.
it does make it easier
yeah.
to generate baseline information. In
So
other
it's
words,
improving the accuracy of what
Yes,
and the
yes,
reliability
absolutely.
of what we're getting.
and then we can design treatment adjustments for
Yeah.
what we're actually receiving.
Yeah. Okay.
This is gonna, when we embark into like the wastewater master plans, having composite information is crucial and all of the myriad of constituents that you can be gathering. So even getting those units online and starting to collect some data is going to help us tremendously with the master plans and
what we need in the
moving
future.
forward. Yeah.
Wow.
Okay, well,
Awesome.
that's good. That's
That's what we want.
sounds like a huge improvement.
So this is locked up, but the good news is I don't have a chain on the back yet.
Oh, wait!
This is not.
Sorry. It's a very secure system. you got.
Just kidding. Did we
So
get
is
lights?
this for storage?
Yes. Well, you're right. It's warm in here.
It's warm.
Oh,
You need those little
We
bed
gas
fans.
this thing.
Oh, you need a few 2 more, one's not enough.
Well, I can see right now that this is gonna be, yeah.
A little toasty.
Wow, there is a lot showing there. You're right, Justin. We are ready to go with this thing.
Yeah, we are.
Now, this is storage for what? For the district?
Yes, district
You
officer.
mean that conference room's gonna be cleared out?
Yes.
Yeah, that would be nice to have that.
Yeah, they
space.
can-
Yeah,
have
no,
space back,
it's
yeah.
huge.
Yeah, there's actually a few items right here.
Yeah, that's good.
Yeah, we've started. We've started.
I have
So-
to say, this looks very impressive here. I mean, I remember
Clean.
the first
I was
time.
thinking the same
Oh,
thing.
before we even had
Toilet
this,
papers were all
Yeah.
over the place.
Yeah, so-
and things.
before Justin's time,
Oh, yeah.
the headworks here
Yeah.
was a manual
Manual
system
thing.
with a
Right.
pitchfork.
Yeah.
Yeah.
And we had a pick,
Nasty.
and you just scrape it out, and it was, yeah.
Yeah.
So we got that donated from the city of Paso Robles, and then this we had further headworks improvements a couple years ago to do the bagging system and the dryer compactor. So yeah, you're right. It's a lot cleaner for sure
Yeah.
than it used to be, and a lot safer.
Yeah, it allows you to put things like that close by, and
Yeah.
it gives you more room. to
Okay,
do
moving on,
stuff.
it's pretty right.
Okay.
I'll just, for the sake of it, because we were talking about the ultrasonic, for those that want to take a look, this is called a partial flume, and this is got the ultrasonic over it and it's reading the flow. It's totalizing the flow passing underneath it. So this is the numbers you were seeing inside the lab. The flow
Wired
totals.
there.
This is a partial flume. That's an ultrasonic sensor, and so then that's where we get our flow.
And that's just the pump.
No, it's not.
It's not related.
Not related. Not re- yes. Here we go.
Now, those look thinner or different since we were last here. I don't know why, I thought they were just more upright instead of the width.
Oh, well, there's this style. We had over here these other types of aerators that are not on right now, but we over the last say 3 or 4 years we've added some out here. We've
Well, I
repositioned
knew
them.
we
Like that one
added
there.
them,
It
but-
started out in that corner. This,
But they
Yeah.
look like a different style than what we previously had.
these
And
ponds
maybe
always
I'm
had
wrong,
this style.
maybe-
There was a donut in these other two over here.
Yeah, there's a couple. We even have ducks now. Look at that. That's how
all
clean
new.
the water
It's
is.
all- it's all new. Celebrate.
They have to bring in the wildlife. It's not killing them either.
Hey, I bet you if you get some grant for that, you know?
Yeah.
Wildlife preservers,
Yeah.
you know, you gotta.
It's environmentally friendly.
Exactly.
Some of the staff were asking about, that's interesting about the wildlife. Some of the staff were asking recently, we had the Gaffney bloom inside of the last pond. The Gaffney is a kind of a crustacean. It looks kind of like a, if your kid had a nice kind of kid at home and the kind of a blind shrimp, the little shrimp things that are in there. And so in labs, Daphne is used to gain insight into the toxicity of the water, and if they're able to stay alive, then we're good to go. If they die, then we have an issue. And so there was a huge Daphne bloom in our bottom ponds, and I was just explaining to staff that that's okay. You don't have, because you may be worried if you see this giant red. It's bright red, so the entire pond turned bright red with this Daphne bloom.
So you remember that the water from the headworks comes into this and splits to these two
Yeah.
treatment systems. And yeah, this is the area we were trying to, a couple years ago when we added aeration, just to try to figure out where to place it. And we started out with one in this corner, but it didn't end up working out well. So they've been moved around a little bit. I don't think we've moved them much since you've been here. They've been stable.
Yeah.
Yeah, I remember that you could see there were areas where the water wasn't moving at all.
Yeah.
But now if you look, you can see everything. The
ripples.
moving.
Yeah.
There's ripples everywhere.
If you imagine these ponds, these first 4 ponds, they were designed by the Professor Oswald, and they're the AIWPS systems, right? They're the Advanced Integrated Wastewater Pond Systems, and so they were designed to load full of solids, and then the bacteria would be able to stabilize the biosolids, so that you would never have to deal with sludge at the end of the day. You would never remove or waste sludge at the end of the day. But as you know, there's that project to remove sludge finally. And so we're still working on that as well. There's deep zones you can imagine inside of these ponds where it goes much deeper, and they have these digester zones where those bacteria, those solids are supposed to set up and then be further reduced by bacteria. So it's just not static, the bottom of these ponds. It undulates.
So these are older aerators. They don't have these aluminum
Oh, yeah, those
plates.
seem like
Yeah.
this
So this is what we found. This is an improved style of aerator. Those plates on the side keep the water off the motor components and give it a longer life.
Oh yeah. Makes sense.
Yeah, it's sort of simple.
Yeah,
Right?
yeah.
Yeah, they're actually different sizes. You can see over here, the one's much larger than the other.
Yeah.
I think there's everything from 5 to 10 horsepower brush aerators in these ponds. And most of your treatment's happening in these first 4 ponds as well. What the one chain, Jeff, was built to a 300,000 gallon a day capacity, and the 2 chain was built out to the 600.
You know, all the ponds are full.
They're all
everything
going.
Is, yeah, they're all. This is what you want. You know, before it was like some of them were, empty.
Okay.
This is what you want, so that way you keep.
I always have to walk down the
Yeah.
little.
You know.
You don't want to get too close.
I understand.
It's like,
no problem.
yeah, I don't want to get close to the edge.
No.
That's the
Yeah.
Whoops, I bumped you.
No, I know.
Water from
Yeah.
passing
You have to be
Yeah, to
water.
really safe around
Get these stuff
ponds.
working
Yeah, I've been trying to
properly.
come out with like getting them licensed, those sorts of things.
Oh, yeah.
Much more better.
Because you really have to watch it.
Even the way it was going down so
Work with
fast.
people that have
Yeah, well, you know, it's I think it's been a lot more steady, stable for about 2 years now.
Like just on digital stuff and stuff like that, data and things like that. So I think that's beneficial too.
Oh yeah, getting a better handle on the data.
Yeah. Instead of waiting a month to get the data, and then when you get that data, it's useful. So that would be interesting as well for the DoD. When we get more accurate results, because we are having programs for that too, like customer and commercial.
Yeah.
So it could help.
So
some of the wind blowing
Yeah, everything here.
towards the back.
well, here's some evidence you can see where we're not getting as much circulation.
Yeah. We were just talking about that. Justin seems to think it's the wind that's kind of blowing it in that direction to bring it over.
And that's typical for pond systems to have kind of dead zones towards the back of different ponds where solids would build up. And that's in part of our plan is to have a contractor come through here and pull some of this material out of here. Valuable space that the sludge is taking up. Instead of it being like treatment space, it's just kind of sludge.
Is there anything you could do to like add another aerator or anything like that?
You
or-
can't.
To line them differently.
Yeah, you can't. The material is, unfortunately, it's going out of the first floor where it's supposed to stay, and then it's just going downstream at this point. It's not staying in place. So if we pull some of the material out, then they will bias. I don't know how often we're going to have to pull sludge out of these ponds. It may be an infrequent sort of basis, but we're entering those master plans. That's where you identify all that stuff, anyways. Because we're outside of a design anyhow, using those storage lagoons, using like this as for treatment. So that will help identify all of those things, anyways. Yeah.
Yeah, you might remember we converted. This was a wet weather storage pond, and we did an emergency conversion to treatment because we weren't getting sufficient treatment for the volume. Wasn't the water? If you remember, a couple years ago we had this talk. It wasn't the amount of water; it was the amount of loading the plant took. Once we connected with Paso, we think it was probably most of our industrial areas
Yeah.
overloaded us, and so this is part of the completion of of the treatment. Now, this was designed to be a wet weather storage pond, a place to hold treated wastewater when we couldn't dispose of it.
Yeah.
So,
So now we're using it as active treatment.
yes.
So we want to go back.
Well,
Alright.
no, not necessarily. We just need to analyze what volume of wet weather treatment do we need to have, and maybe that gets replaced somewhere else. You know, we have that enormous pond down there that holds, you know.
Was it also part of the east side being brought over into this treatment plant instead of West Casa?
Well, that's what really.
Kind of the larger quantity, and then also
It's the loading, right?
Yeah.
Not the volume of water, but
Yeah.
what's in the water.
Yeah. Well, and then you had all the Twin Cities came with it.
So, but now we've been in a sort of steady state for a little over 2 years.
Was this the one that you said the valve was broken on?
In between, when we get over to the, you see that float in the water? The little pond, that float, when we get over to that side, you'll be able to see exactly what I'm talking. I can talk to that float and I can talk to that valve. Yeah. The jacuzzi ponds. I didn't come up with that.
I was going to say, you got to do humor.
So here's an example of the other style of aerator. It's just not on right now.
Yeah, oh yeah. Yeah, that's what I thought we had over in those first two ponds.
What the difference is in aeration, the brush aerator is meant to aerate the top so many feet of a pond. And so then those are not meant to influence from the bottom of that pond to the surface at all. That's a facultative lagoon, which means it has an anaerobic bottom layer where those solids are, anaerobic bacteria breaking down those solids, and then you have an aerobic oxygen-rich layer on top with facultative bacteria that thrive with oxygen. These types of aerators influence the entire column. Wherever they get installed, they can influence 10 foot of depth, all the way from the bottom, complete mixing, aerating the entire contents of that pond. So they're just different styles.
Yeah.
And so where are they now working right now?
This one was taken off. This one was taken offline before I came here to kind of as a storage of solids because they were coming out of the first and second chain. And then
Okay.
by kind of like default, it was kind of a similar situation. Remember, we're working out of a design right now, right? So even with the addition of the aeration in the 1 and 2 chains, we're still kind of, I know there were studies and there was recommendations, but that master plan is really going to speak to exactly what type of aeration, how much aeration, where the aeration's needed, solids, what interval they need to be taken out of the system, all of those sorts of things. There's so much to be gained to identify in those master plans.
Yeah, what was happening is what we were finding is that there still was some of the sludge was in the water and it's making its way towards our point of discharge, which we absolutely can't have, right? So we want to keep all the solids at the plant.
Yeah.
So these completely mix up the entire contents. So rather than, and you'll see that on the third
than
one,
having
you'll
it
see it
settle
aerate.
through.
There is another one. So instead of let it settle for a second,
Yeah.
and then we pick back up a little aeration right here.
I see.
Yeah, that's what the thought process.
How often do these liners need to be replaced?
I don't know the lifetime expectancy with these liners, Jeff. Have you heard anything?
No, I mean they're not a forever product, but
Yeah.
they've been here since the plant was since these ponds were put in. So we have had a couple of
So the
repairs,
master plan
and
would address that
we
as
have
well.
we have equipment to repair it now.
Yeah, that's
Sounds
right.
like we would have to know each pond and what needs to be replaced, when it needs to be replaced.
Yeah, absolutely.
Be able to account for
Yeah, how fantastic. I live for this stuff. Yeah, this is great.
Yeah, this looks like it's getting really good circulation too.
Yeah.
So before this pond was put into use, we discharged directly out of this down to Selby.
Yeah.
Now it's coming from here to this third pond, which was also essentially bypassed previously. Although that's not really treatment. It's I guess there's probably something happening in there. But so we've added essentially. This is a lot of additional treatment that didn't exist previously, originally.
So from there, it's coming over here, right?
Yeah, so the 1 and 2 chain
Yeah.
over to this smaller pond, these two, and then finally
In sequence.
here.
In sequence.
sequence.
Yeah.
1, 2, then 3.
So even though, I guess, how does it coming over? Is it gravity?
Just the
or-
pipes. Yeah,
The pipes underneath.
yeah. There's
Yeah, with
pipes that go
gravity.
from one to the other. Yeah,
Yes.
yeah. there's
Everything-
no
everything here
force,
flows
it's all
on gravity.
Okay, and then but so but so that those don't need to be aerated. You don't want to stir things up and then it comes over here, and then it could get aerated here because it settles down.
So
it has
it's taking
settled
really
down.
kind of the top what?
Top.
How many feet? Because it's not taken from the bottom.
Yeah. Okay. So the pipe, you can actually see
Yeah,
the
you
pipe.
can see the pipe. So that's why I don't know how it's getting over because that one the pipe was exposed.
Yeah, but it wasn't before we did this filter study.
There it is.
Everything was lowered to do this filter study. So this is a recent development. Normally, you'd see another you see the white mark around the pond.
Yes.
That's where the pond
Okay.
would be.
So all right. So is right now currently any water going there? Because
Oh, yeah.
the pipe is. So how? Because the pipe is.
Yeah, so then you can see the top of the pipe, but so then
Is there
80% of that pipe. Yeah, that's a T.
So it's-
I'm
okay,
sorry,
it's
that's
a
a
T.
T.
Oh, okay.
And so just
I
to
see.
keep debris, solids
I
from
see.
going in, wildlife. I hate to say it,
Yeah.
but things
Yeah.
do. They go into
Yeah.
they find their way into
I
these
see, it's a
ponds.
T.
Yeah.
All right.
And it's just a way to protect that inlet,
Okay.
so you don't flood. Yeah.
Okay. Nah.
You're like keeping the liquid.
And to your point, as far as turning off on, some of these things are you make a change. You try and keep as many variables. You try and limit make one change, track the results. Make one change, track the results. So if that is a good or bad move, you
know.
collect
Adjust.
data and adjust as needed. So.
The hard part about what Justin described is then at the same time you're working with the clock, right? It takes a long time for the results to show up.
Yeah.
So if we make a change now and you measure those results a month later or 3 weeks later, you don't necessarily know that it was the change that made the difference, or was it the season?
Yep.
Less daylight, cooler weather, all of these things
Temperature.
factor into the results that you receive, or incoming water quality.
Yeah, I've reviewed a lot of data in the beginning since like the 2019 when we started taking more flow, but I started to gather more data that's from, this is control station 4. This is through the 1 and 2 chains, and then the small jacuzzi ponds. This is the effluent going into L. And I'm trying to understand what is coming in and out of this structure, what's coming out of L, and what's coming out of K. So these 3 ponds tell us we should see a kind of a consistent drop off in each of these 3 facilities in TSS and BOD. And we're seeing that, the idea is that we set things at a certain elevation, we set things, and then we don't, because we're operators, we want to constantly be pushing buttons and levers and opening up weirs. And so the idea is that we set things and then we track and we collect the data. And if we're going to make changes, it's going to be based on the data. It's not going to be based on, our operation, our
feeling.
need to change and push buttons. So we're
doing something. Yeah.
we're doing.
Which way would you want to look this way?
However, if we're going to walk this way, let me just say, because you had questions about the valves.
We'll go this way then.
And so this float, come to find out, so then on this, there is a measuring device inside this pond. And so this pond is 7 foot deep right now.
Okay.
And so right here where this float is, there was a riser pipe put on it when they turned it from storage into an active treatment pond. They added a riser pipe so that it takes water at a higher elevation from this pond over into K. And so I think we're going to end up, Jeff, taking that riser pipe back off. The reason being is that then we're operating this pond really close. We're operating this pond fairly, not right now,
but normally we're operating this pond at about 9.5-foot elevation. The intake piping now is at 7 foot, so you're operating at only 2.5 feet from the surface, and you're still in that zone where algae breeds. You're still in that zone where algae blooms, and so we're going to be taking off that riser pipe, lowering it so that it's pulling off the bottom of the pond, so that algae can kind of stay, if it wants to bloom, it can kind of stay up in that upper level, first few feet, and it's not going to affect, the next downstream pond. So
To do that, you'll drain this. We'll take the pond down quite low, and then.
Yeah, right now we are right at the pipe. The riser pipe is right there, and so we'll have to take it down lower to be able to
Couple feet.
remove that riser pipe. Now, then we had assumed that we were operating K at an around 8-foot depth as well, and so it wasn't really until we installed the this equipment into the pond, because there isn't a measuring stick to gauge, and so
This is really deep.
so now we've built up this pond, the level, so that we could operate their equipment and their pump. But when we lowered the pump in there, we found that we were only really about 3.5-4 feet deep. That's how we were doing that, because we needed access to inside of the pond to a valve that we needed access to it, because a valve at the back of this trailer ended up breaking some years ago. And so to still gain control over the water coming from L to K, staff were going down the liner and then adjusting what's called a butterfly valve. It just has different notches, and based on the notch you have a certain flow going into the pond. But then, so come to find out, here we are, we find that in doing so, in maintaining access to that butterfly valve, we were operating that pond at only like a 3.5-foot depth. So we're gonna replace this valve. It's a 12-inch gate valve in the back of the trailer there. That gives us more precision, that makes it a little bit more precise in delivering the water from L to K. But it also allows us to be able to build the level of K. We shouldn't be operating any of these ponds at 3.5 feet deep. So that's going to help us too. Again, we'll be drawing off the bottom of K, right? We'll be drawing off the bottom of K, and hopefully that algae bloom will be at the top, and we'll be pulling off the bottom. We won't be pulling algae necessarily right over to Selby.
Wow.
That's
That's what we're trying to avoid, right? Is no solids go into Selby. Does it really matter what the solids are from when it comes to Selby? Anything thick plugs up the sand. Whether it's sludge or algae or other items in the water.
If we could, just for a moment, I'll tell you why we picked this spot for the study, the pilot study, because that's where we're about to walk down to. And the reason why we picked this location, it's got 483 phase. It's one of the only places that we could tag into our panel here. This is our main service. It's got 483 phase, 400 amp service right here. So we connected into that. We have a drop cord into their unit. They're able to pull off K. They're able to waste into this concrete DI right here, right? So they're able to pump water out of K through their system, waste to this DI, and ultimately over to the M storage lagoon, and then be able to discharge right back into K, and it goes off to Selby. 15 milligrams per liter TSS is coming in, 1 milligram per liter is coming out. It definitely, it's a low, what's going in, it's a roll of the dice if you're going to have high strength TSS water when they come out from Florida or not. And we just happen to have really low right now TSS. It's just the way that it is. So he has offered, he'll tell you, he has offered to take his results and kind of go back to Florida, and if TSS builds back high again ever in the future, to sample, bottle those off, send them off to Florida, he'll run, and then kind of run them through his model, some of the information he collected here, and see, and give us back some kind of results, because we just have really low TSS right now, and the weather seems to be, I don't really have an explanation. It's been warm, it's been sunny, but our TSS is really low right now. It just happens to be that way. So,
but still, even though it's low, it's taking. You say it's taking it down from 15 down to 1.
Yes.
So the system is working well.
Oh,
yes,
absolutely.
but what we don't know is we have peaks where the TSS gets to 50 or 75 or even higher. Will
don't
it?
know
Will
what's
will
causing
it?
it.
Will it? Well,
That's
it's
what
a
we're
whole
trying
lot.
to
It should.
That's
It
what we're
should.
trying to
It
get that
should.
consistency.
But that's because really, if we had 15 to start with, steady year round, we wouldn't be exploring a filter.
And we're trying to get there.
Yeah.
We are
If-
trying to get there.
Right. The lower it is, the less need there is. At least at Selby. Now there could be a need down the road for this level of treatment either way. But yeah, we've had spikes where TSS has been much higher,
Yeah.
leaving the
Yeah,
plant.
but what you're talking about, Justin, in terms of adjusting some of the valves and water levels, it sounds like we will have a little bit even better control over that.
We do in the plant. We don't. What we don't have much control over, or hardly any, is what comes into the plant,
That, yeah.
and then weather.
That's-
There are these
yeah.
couple times a year when we have very unique weather here in this. We have quite cold winters and pretty warm
Extreme
summers, and so the water. There's some periods of time when the ponds will actually turn over due to temperature and
Yeah,
sunlight
that's right.
conditions. So it's really really unique. What happens in other parts of the country, may or may not be effective here. But 10 years ago there was a real concern that 10 years and maybe 8 to 10 years that we had really sludge that was making its way out, and that was one of the things that was harming us. I think we've got a much better handle on that.
Yeah.
And then actually just putting more ponds in service means that the treatment time is a lot longer. So there's more opportunities for things to fall out of the water.
I would hope that we'll be able to, down the road, come back to you and report on after a few changes are made and we've tried to the best of our ability to kind of set things and now just collect data. We can come back to you and report to you. How is that going?
Yeah.
Is it trending in the right direction? Or, yeah, I'm anxious. Trust me, I try to be patient, but I want to. Inside, you want everything instantaneously, and waiting for TSS results from the lab sometimes for a month is it's tough. So.
No, this is good.
So anyway, the water comes from this pond to this pond, and let's walk down and we'll check out this filter project. And
Krishna.
On this one?
there's a little. This is probably the easiest way here.
Yeah.
This is the country.
Yes.
Yeah, I'm surprised I haven't. I'm just right through this whole thing. I'm just down.
Oh, are you?
Yeah, and so I'm surprised I have a lot of. In the last 2 weeks, I have a lot
Oh, yeah.
but luckily
Are
never.
Kings makes the top ones?
Yeah.
So this system, I guess it would be a much bigger setup
Yes,
to be able
yes,
to handle.
yes.
Well,
Yeah, these are sized just for these pilot studies.
Krishna, afternoon.
How you doing today?
Good to see you again.
You're good to see you. I hear you're about to leave us already.
Yeah, one more day. Good to see you.
Good to see you. This is Naveed
Hello. Nice to meet you.
and Deborah.
Hello. Nice meeting you.
So
Here we are. And that's where we are getting our feed from. And ultimately, if this were to be the solution, this is going to take the water from this last but one pond before it goes to the perk ponds. And so we have created the float system so that the influent pump is 2 feet below the surface. And that's ideally the case where it would be flowing out at that level.
Okay.
When it's usually maintained around between 8 and 10 feet. Let me walk around, show you, and then we go inside. The taller one usually uses a coarser media, which means the sand media has got a bigger diameter. And then the smaller filter, you'll use a finer so that you do the better polishing. But in this pilot, for this application, we only need one. So especially with the high algae expected during summer months, So you would have to use much coarser media than you would normally use for a tertiary filtration. So we are using 1.7 millimeter as opposed to 1.4 millimeter in this case, so that it can hold more solids.
Okay.
So it doesn't escape.
Yeah.
And so that we're only using the larger filter there. So in the future, for any reason the regulations change where you want even better removal, then the water flows from that by gravity to the next one, the shorter one, and that will do a finer polishing.
Oh.
It could be any number of reasons, phosphorus regulations and
Yeah.
groundwater discharge, anything that can come up. And so that's the reason why we always do it with a deeper bed for a single stage.
Okay.
And here, this line here is the same line that there's a flow meter inside this blue box that's coming from the pond. Feed water goes through here, and this is where we inject a chemical. The chemical is alum. It's aluminum based. What it does is that it coagulates, it bonds into tiny algae particles so that they get accumulated together so that they get trapped in the sandbed.
Oh.
As opposed to them being colloidal all over the place, the chemical helps them coagulate. And there is an inline mixer in here. It's just a static mixer that mixes the feed with the chemical. And as it goes in with this green hose that you see, right?
Goes up there.
It's
Yeah.
not this one, the one behind this. And that goes into the sand filter. We'll go up there. And water enters the filter at the bottom. It's coming from the top, but it goes through
Yeah.
to an
all the way
annular
through.
pipe to the bottom. And from the bottom, the water, dirty water, percolates up through the sand bed. And the sand bed is about 80 inches inside this tank. And so as the water percolates up, all the algae and any other suspended solids gets trapped in the sand bed, and then the clean water comes out. And then it flows out over a year, and we are discharging back into the pond right now. And what happens now to the dirty sand is, there is in the middle of this filter, there is an air pump. We call it an airlift. And we inject air through a nozzle all the way to the bottom of that. And it lifts the dirty sand from the bottom and brings it up the middle. And as it brings it to a bowl in the middle, now what happens is, there is a portion of the filtrate, good water, coming through the treacherous pattern, like a 45 degree, like this concentric rings. It goes through the middle there. As it comes up, the sand that brings the dirty sand, which has got all the algae and the suspended
The
solids.
waste.
So because the sand is heavier,
Yeah.
sand wants to fall back to the bed. As it goes down through the path, this clean water lifts those solids up into the bowl, and it goes out the reject.
Huh.
So the sand gets cleaned that way. It's a continuous filtration and continuous washing.
So would you call that something like a continuous backwash?
Yeah, continuous filtration we call it, where we don't stop the
Right.
filter to
Yeah.
backwash.
Yeah.
And
but
it
the-
happens automatically, or how often does it happen?
Yeah, this all happens automatically. And as soon as the
There's
water
the,
level
there's
reaches
the air right there.
something at the filter, the effluent level, the airlift comes on. And that gives the signal. And so now, when the water level goes below, automatically everything stops. This compressor goes on and on because it's just refilling the cylinder bank. But in a regular application, you'll have a much bigger cylinder that will have a larger holding capacity.
Oh, okay.
And there are a
What-
couple of ways to look at it. Yeah, go ahead.
Yeah, what's the fresh water for? What do you,
Which
this hose you're feeding.
Oh, this hose, I'm not feeding, it's there to clean up and
Oh,
also to do the chemical dilution.
Oh, okay. It's not
used
part of
for
it's not
the
it's not part of the
treatment. It's
treatment.
not for the treatment. This chemical alum that is sitting there is 50% concentrated. So that's what you
Oh.
would use in your full-scale installation.
So you're leaving tomorrow. What are we gonna do with the big crate of alum?
I know, it's going to stay until you buy the filter. See, now you have some vested interest.
See,
Right? You
you,
gotta
you,
use
you're
the
getting us hooked. I see.
So wait a minute, he's leaving and all of this is going, or
Yes.
he's leaving and this is staying?
No, this is going to be over tomorrow. We
Okay.
did
Tomorrow is the
This is
last day of
a
the...
10-day trial, and it started 9 days ago.
Yeah,
Yeah,
9 days ago.
okay.
And 8 days ago. Today is the 9th day and the 10th. And
Okay.
so now,
And when do you get the results back to see whether or not this has been?
We're getting results on a daily basis.
On a daily basis,
We are doing.
okay.
We have the
Okay.
on-site TSS now. Eric is doing it, and
Okay, good.
we're getting the results. I get the feedback right away if I need to make any changes to the chemical. Usually, what happens is that these chemical are either higher dose for more algae, lesser dose for less. If you have conditions like some of these days, you may not need anything.
Yeah.
And at the same time, this continuous reject flow, the water, you don't need to do that if you have a lower amount of algae in there, like winter months, and probably except for 3-4 months out of the year in summer, you could still not reject and not use the compressor for majority of the time. What happens is that as more solids come in, the bed becomes more dirty. So it creates a layer of dirt in the bed, so it fills all the void spaces, so it becomes a better filter if you don't wash it continuously. And so your effluent quality goes up. And then it has a sensor already, which is the head loss sensor. As the resistance for the water to flow through a dirty bed goes up, it senses that, and then it starts washing.
Oh.
If it doesn't go threshold level, you don't wash it.
Oh wow. And it's all set up automatically.
Yeah, it's all set up
Wow.
automatically.
Maybe we should walk through.
Yeah,
or-
now we'll go up
yeah,
there.
it's getting hot out here.
Let's do it.
I'm melting.
There we go. There we have it.
This is a lot of 270 gallons here.
Always. And I think that was partially because there was thought that we were going to see much higher TSS levels, Jeff, so that they would have to use a lot more
Yeah.
chemical. But I think it's going to be after this, working out with Brintag, how much they can take back from us.
Oh, they might be able to just buy it back. Or,
Well, that's what I'm hoping.
Yeah.
We didn't
Partial.
do anything with it. I mean, it's still good.
still right there. Get a credit or something.
Yeah.
And it's washing, the head loss, all these parameters are showing here, and what the flow is coming through. And here, this is the turbidity. This is for the effluent. The sensor goes up all the way into the filter. This is what we're getting the quality of the water right now. This influent number, I draw sample every hour to check here what's coming in.
Okay.
So it
That's
gives
what's
me-
coming in.
Yeah,
Okay.
and that's accumulated over a couple of days.
Soon, I'm sure you brought your water bottles with you
Yeah.
because we're going to be filling them on the effluent just to take part in a demonstration.
I got that.
I don't have water out.
Is that what comes out?
Yeah, that's what's happening.
So that was
Yeah.
Well, there.
Typically, you won't remove the color much. You'll remove all the solids. But, because of if you remove most of the solids, automatically it will have less. And I have a calibration column here just to verify the accuracy of this. Whenever I reset the amount of dosing, I recheck it. That tells me how much is flowing, just to confirm the accuracy.
So, if we have this place set up, what's your expectation in terms of manpower? Do you need one person full time?
Just
or-
like anything else in this plant, a person can periodically check on it. They don't have to be sitting here babysitting it.
24/7.
And, yeah, these are very reliable, 24/7 hands-free operation, and especially with the more controls you have, you will even give your operator an alarm or something if something is wrong, and they will get a beep on the thing, and they can attend to it. And, one at a time or two at a time.
I'm not going to go up.
Yeah. So that just goes there, and then you have to
And
set
then
water.
that's the water that's coming out.
I think it's a liability.
I've been up there.
And you can literally see the sand falling back clean
Yeah.
into the bed and all because the sunlight is good at this
I'm going to trust what you say is happening.
Well, and we have a model that you can you may remember when we first started looking into this technology.
Oh, yeah.
There's a model that shows how it all works.
But I can go first if you want. You can follow me.
Okay.
Just so you. Yeah.
Now we got 2 board openings.
That's okay. We got 4 interested parties. I'm good to.
I'm going to stand back here in the shit.
Yeah, please.
It's hot.
Yeah. And that's what I mean. We had times even last week when this was up
Oh
and
my
running,
gosh.
and we got up to 98 degrees, like a week ago. And so it's not been the lack of high temperatures. It's just we're just not getting as much of an algae bloom as we've had over the last 4 months. We've had spikes. We were starting to drop down before we had this study. We were starting to drop down, and that's what we've been continuing to do is just kind of drop and hold.
Yeah.
So.
This is the water that's going out from the spike here.
That's clean. Take a picture.
Wow. I mean, right now
Yeah.
it's got less than 1 milli. TS is 1 milligrams per liter. Anything less than 5
It's just kind of,
is
there's not
detected.
much. I'll take pictures. I've been taking pictures of everything, so I'll take more pictures up there before
Just
the
turn
sun shuts down.
backwards. Okay.
A video.
And this is the
Let
air
me post a
control
video.
panel that supplies.
I'm not climbing up there.
I'm not
Justin, is this foam a byproduct of the alum, or is that just a movement of the water?
Yeah, I don't know why it foams so much. I don't know that the reason is because of the alum or not, Jeff. It does foam, and I don't. Krishna,
Let him take care of the safety issues.
Yeah.
come here.
Yeah. Yeah.
Is this? Is it like a trusting thing? What do?
Oh, you're gonna let him fall back?
Oh, I missed my.
We're already.
We lost someone.
Well, at least it wasn't you, Naveed. It was only your bottled water.
Jeff was talking about the foaming out of the discharge.
No, it's
Effluent.
yeah, it's
Is it
not
because
really
of the
foam.
chemical?
If you go look up there, the water, it doesn't foam. It's got something to do with the way it's flowing out. You saw the water, right?
Yeah.
So it's just a movement or something.
And here, so I'll show you the water here. So this is the water.
Yeah. Right. Yep.
Yeah, that's
Bottoms up.
You don't want to drink it.
not yet. No,
So, but
needs
this
all the
is enough.
chlorine.
there's
Just,
no chlorination here. No disinfection.
Disinfection.
but it's enough. It goes into cell B and then gets
then it
percolated, and then that's it.
The clean water.
Yeah. Then it's
So
after.
because we don't add, okay, and then you got add chlorine at the tanks, right?
Yes, yeah, chlorinate the
Ground
drinking
it,
water.
Yeah, that's
Just-
the last step.
Wow.
So yeah,
Come
it's
inside
groundwater
the shade
after a
if you
month
guys want.
in the ground.
Yeah.
It's too hot over there.
Yeah.
But it takes 2 or 3 years.
In our situation, but not in the long term. I mean, well, yeah, from Selby, it will always take. Yeah, just because the travel time under the river, right?
Yeah. These
Does it have to be that
have their
clean?
own shed.
For it and for the get to
No,
sell?
no.
So it's an overkill type
Well,
of thing.
remember, we're only treating a little side stream right now.
Yeah.
You know,
If
this-
there's 350 gallons a minute coming in, we're pulling right now around 50 gallons
50,
a minute.
48, yeah.
48. And then we just again it was the luck of the draw. We're dealing with 15 milligrams per liter ish.
It's coming in.
We're not dealing with 80 milligrams per liter TSS. We're dealing with 15.
We can really time the algae bloom to do the study, but Justin is going to send me the worst case scenario whenever it handles samples. And I have a lab scale test, and I'm going to do the test there. Between that and what we learn here versus our past experience, we can have a comfortable design.
Awesome. So what TSS level can Selby handle? So like
well, the higher,
yeah.
the worse
So
it
like
does.
but like
Yeah,
if we
I
get it
mean-
down to 5 or 10.
Oh yeah, even 15 would have been fantastic.
Then typically 15 to 20 is okay.
That's okay.
Yeah,
All right.
as long as you don't use any polymer as a
Okay.
chemical,
Okay.
then it goes and blinds up all the pores, and we don't use that. So
Oh,
that was one of the requirements. We shouldn't use it
Okay.
and still make it work.
All right.
All right.
That's good to know. Wow, very informative. Thank you so much.
Thank you.
Thanks.
Yeah. So you're out of here tomorrow, huh?
Wednesday we got to do all the repacking and all that, and Thursday is going to get picked up.
Where are you going back to?
Florida.
Wow. How are you going to get there with all the...
No,
Yeah.
he came from Florida, but let me.
Actually,
We're in Florida.
this in Boca Raton, South Florida, 40 minutes north of Miami.
So is this the sand over here?
Yeah, that's the sand.
Okay, good. Remember, I couldn't see it last time because it was packaged.
The excess sand. This is clean sand, it's inert. We can cut it.
So yeah, it's pretty coarse, huh?
Yeah.
Yeah.
So do you said you could you use 2 different kind of sand?
Yeah.
Okay, so this is the coarser
This is
one,
the
and then there'd
coarsest
be a
one.
finer one.
Well, it depends on on what we're trying to accomplish. In this case, because we were
Yeah,
trying to
you
get this designed to treat kind
The
of
worst case
high
scenario.
TSS water with a coarser sand, like a coarser filter.
Yeah.
But even out of this sand, we're getting good quality treatment.
Yeah.
Even though we're not getting good solids, in terms of heavy solids, which is worst case scenario,
Yeah,
right?
yeah.
Good is for the treatment. But whenever that happens, we can still manage it with the eco wash, where you artificially create the dirty bed by not washing, and kind of simulate the higher TSS condition, and make use of the same sand.
Okay. Alright. Wow.
But this sand came from Texas.
That's right. Yeah, that's right.
But you're going to find us some locally if we go this
Oh,
route.
yeah,
right?
there are mines here, and because of the last minute getting somebody to supply, we got it from there.
How much sand do you use?
For this, it was 3.5 super sacks, which is about 6,000 pounds. That's one sack. But you don't lose the sand. It is.
That's what I was wondering.
It's
So
inert,
once you get it,
inert.
that's
Yeah,
it.
it's forever.
And Krishna, you were talking about the life expectancy of the sand is a lot longer than I thought.
Yeah,
What
he
were
said
you
like
saying?
10, 15 years.
10, 15 years. The reason for the life expectancy is not because the sand has become powder. It's because like 1.7 millimeter may become 1.5
Where's
over time, varying, right? And still it will do the filter. But what happens is that by that time, some people, even after 5 years, because they didn't operate the filter right, and because they didn't take care of let's say everything is crooked or something, they didn't reset it when they took it out for maintenance or whatever, and then if it wears out faster or the filter gets a lot of external things, it could be mice, rat, any number of things, right? And it becomes dirty. So they're like, oh, I want to recondition it. Then they will say, you know what? How much it is to get new sand? We might as well just get new sand. That's what happens.
Oh,
Well, thank you, Krishna.
Yeah, this was great.
Sir,
thank you. Appreciate it.
thank you.
Thanks.
That
Hey,
fellow John,
Thanks
who,
again.
who used to be a Cal Poly student, and then he's affiliated with some of the equipment over here
Uh-huh.
on the South Fluid side. He was going to stop by. He was hoping to talk to you about this process, like at 3:30 or so.
Sure, no problem. Okay.
Okay.
Thanks. Have a good one.
Thank you, sir.
I mean, you get something like this, don't need something anymore.
Well, the Selby's benefit is really to make that water available for us as a water supply, right? That's the real purpose of.
Yeah, but can we speed it up? If we get it this place?
Well, it's the issue is how reliable can we put the water in the ground, right? The lower the TSS, the more reliably we can discharge more water.
From Selby into the ground.
Into the ground.
But I know, like with so what we're doing at the side ranch.
So putting a well
distance
closer
is
to
distance isn't as far. So we get the water back in a
Couple months.
couple of months versus a couple of years. So can you speed that up, or, to get it?
Yeah, a well can be moved closer, but then we'd have to put all the infrastructure to get it closer. But really, we know it's there, right? Once it's in the ground, you know it's coming. It's not like it's in a batch because it's continuously.
Yeah.
It's like continuously available. So that waiting time is only a factor initially.
And then another thing, though, if it's this clean, Selby could process it faster, so you could put Nascimento water in there, more Nascimento water.
Right now, we're taking 400,000 gallons a day of water, right? 400,000.
Yeah, still.
We're taking.
Nice.
Oh,
More than we
Yeah,
ever.
yeah.
amazing.
But the conditions are ideal, right? We're 3 years into a drought. Oh yeah.
So, a couple of years down the road, we shouldn't have problems with water because all this is going in right now.
Yeah.
Trying to do everything, yeah. We can. Absolutely.
So then the creek, okay. So,
But-
so do we have to buy more water then if the Creekside project ever happens?
Well, I mean, remember that's it's still a relatively small. I mean, we have
Because how much water
2,200
can we get from Nascimento?
406 acre feet
So,
maximum.
So we have to buy more or something if they let us buy more, right?
Yeah, I mean, in the long run,
Yeah.
but I think the most important part is the better this water quality is, the more confidence we can have that this treatment plant can treat more water and discharge more water.
Oh, yeah, I was at my friend Nelson gave me a
ride. Yeah, terrific.
It's like, oh, good. It's air conditioned.
Smart man.
Awesome. Great. Well, thank you for the tour. Appreciate it. That was very informative. I mean, I was glad that we were here to be able to see this. I mean,
Oh,
yeah,
yeah,
that's why
yeah.
we,
To
that's,
just be
that's really why we
visually to be able-
scheduled the meeting today was to accommodate
yeah.
this tour, and we thought by now you'd have some preliminary results, and
Yeah.
and
I mean, I could see the benefits of it, and yeah, that's
Well, and
neat.
I can just say that just walking through it, there looks like there's improvement since the last time we did our walkthrough. I don't know if you noticed the same.
Oh yeah.
And I just want to say, Justin, I'm so pleased that you're here. And Nelson was just telling me as well that he joined in July.
Yeah.
And, you know,
Right.
his water certificates also from having previously worked at the San Luis Obispo Water District. So I think that we've got the right team that's on board. So kudos to your
Yeah, no,
selection of
this is
staff.
really-
and so I think you'll provide the leadership that we need to move on to that master plan.
Yeah,
So-
thank you.
Awesome.
We'll be doing our best, for sure.
No, you're
Yeah.
doing great.
Yeah.
Appreciate that. All right. So did we do item 2 then with
Yeah.
this visit?
Yeah.
that was that.
Yeah. So we've done item 1 and 2. That we saw the filter
Has,
system.
Justin, just before we move on, that 15 parts of TSS incoming, that's been steady this 2-week period pretty much.
Yeah.
And
if anything, it's actually dropped. Even at certain days, have even dropped below that. I'd like, I wish I could say that we're
Yeah.
going to be able to continue
No.
that.
I think part of this is, though, part of the consistency is the level of effort to make sure that we're taking in water 2 feet below the surface, and some of those other things too. Correct? I mean, you feel like that's. I mean, where we're taking the water makes a big difference. What makes it a
Absolutely. I
difference?
think a fundamental. So our success in part is hinging all on that, where we're taking water from one pond to another. There's very little control in ponds. Everybody who operates ponds, they'll tell you, they wish they had the buttons and the levers and the switches that mechanical treatment systems have. We have ponds. We're relying on ambient, the sun coming out, temperatures, wind, those sorts of things. So controlling the
Environment.
hydraulic elevation of each one of those ponds is one of the few controls we have, but is crucial in the success of meeting our effluent limitations and ultimately ensuring Selby's health and those sorts of things. Absolutely.
But this system where this filter's taking it off a float instead of off a fixed pipe allows you to. I mean, you could fix that float 2 feet down. That pond could go up 5 feet or go down 5 feet. And it would always be 2 feet below.
Yeah.
So there's some advantages of how this is operating versus how we normally operate, which is there's a fixed pipeline in that pond where the water comes out of.
Sure.
So,
Sure.
So anyways, it's so 15 is that that is I mean that's a great number. If we were at 15, yeah,
When we were
that's
talking about it.
Right. Yes.
No, it's
Agreed.
It's good. No, it's good. Yeah, I mean, I remember, like, he showed us the bucket that had before it went into
Yeah.
the system. It didn't look bad compared to some of the ones we've seen where it's like yucko, So it's
we're getting good treatment right now. I mean,
Yeah.
for the technology that we have.
Yeah.
Remember, this is a fundamentally pretty basic treatment operation, right? I mean,
yeah.
it's just secondary treatment, and
Yeah.
it's a fairly low cost and low tech means of treating. But it is susceptible to environmental impacts or changes, and we can't really control those, right? We get higher strength wastewater in. That's what kills it kills our dissolved oxygen levels and those kinds of things that we were fighting a couple years ago, especially during that first harvest after we brought on the Eastside Force Main project, the first harvest season when crush occurred and everything, and we got a ton of BOD hitting the plant all at once. It was wiping out the BOD down to basically none in the overnight hours. So that means that you're getting like no treatment.
Wow.
So
No,
you
it's-
had mentioned, I think, when I was talking with you about the state water regulators are doing kind of assessments of other treatment plants in the area, correct? We are not included in that assessment at this point in time, but you thought that perhaps we could in the future. If they were to come on site today, how would we fare in your
Well,
opinion?
we're meeting our effluent limitations.
Okay.
We're staying within those. We're not seeing any or even a threat to violating our effluent limitations right now necessarily. The new waste discharge requirements at the Region 3 is rolling out, and it's a systematic. There's 43 wastewater treatment plants in Region 3 from Santa Cruz County through to Ventura that discharge greater than 101,000 gallons. And so even if we haven't been in some of the literature recently or a part of the Regional Water Control Board's presentations, we are discharging greater than 101,000 gallons to land. And so we would, by definition, be a part of those new requirements. And so those requirements, so BOD and TSS, usually you look at first. Secondly is total nitrogen. And I'm surprised our total nitrogen is fairly low for a pond system anyhow. What Atascadero recently has been, because they were a part of the first 12, the first dozen that the Regional Water Control Board spoke to, and it's enrolling into the new discharge requirements. TDS, total dissolved solids, chloride and sodium are the three that are really troublesome. The Regional Water Control Board is rolling out effluent limitations that are connected to the basin plan, and they're just a cut and paste. There's no conversation. And so then our TDS is about double what the basin plan states. So Atascadero has spoken to the Regional Water Control Board, as we would in the future, that installing things like reverse osmosis on a wastewater treatment plant effluent is cost prohibitive. It's the users, the idea of putting reverse osmosis and having our users' rates experience that kind of increase. And then you're always having to deal with the waste too, that brine material, and nobody wants to deal with that either. So we're just going to have to kind of go. We have not been tagged, and we have not been communicated to.
But we're not hiding. We submit
Yeah,
reports.
yeah.
We
No. They know we're here, I'm sure.
We're here. We submit reports.
Yeah.
We consult with them when we have issues. Like we told them that we converted this pond and other things.
So is this what that issue was that came up that one time at the GSA? And so
Yes.
because
Yes.
they,
Atascadero
they're-
mentioned
they mentioned that they're looking into ways to try
Oh,
to.
right. Good. Yes. That is a part of that, because they had consultants, hired on consultants to try and help navigate
Their wastewater.
opportunities with the mutual water company and with themselves to lower, because the mutual water company's TDS right off the bat would basically be exceeding
ours
the
is
effluent
too. I mean,
limitations.
we get complaints
Yeah.
right now about from our. See, we regulate our dischargers, right, like the wineries and breweries, to TDS as well. But their incoming water sometimes doesn't even meet that requirement. We have high TDS water. We're well water dependent, high TDS. That's why everyone has water softeners and stuff.
Yeah.
So our water, our incoming water, is sometimes already in violation of what might be a future discharge requirement. But we're going to know in advance.
Yeah.
They're going to be knocking on the door.
Oh, it's
It'll
quite a
take
process.
years to write the plan.
Yeah.
We'll have
Years.
years
Yeah.
to implement it.
Yeah.
It's going to be very
You
costly.
enter an application process that can take. You have to make good on several reports over about a year period of time, and then you can apply for a TSO, a time schedule order, and there's no sunset on those as long as you're moving forward in good faith. It usually means oftentimes that you're having to build a new mechanical treatment plant. You're getting, for pond systems, it's difficult to meet the new requirements, so you're moving to some kind of activated sludge, a different type of secondary treatment. Biological treatment. Oftentimes, that's what it lends to, because you can't meet the requirements with a pond system. Oftentimes.
Yeah. Okay.
Master plan.
Yeah, that's what
Well-
always came to mind. Is like, yeah, we need that master plan.
Yeah.
Okay. Well, thank you for that.
All right. Great. Okay, so let's go ahead and move on to the annual stormwater report. So we need to review the report and then take public comment on this.
Yeah, so Tina prepared our annual report, which was attached here and is posted on the website. And before this report our obligation is to be able to take public comments on the report. I'm happy to try to answer any questions you have about the report, but really it's an opportunity for the public to comment on the report. I cannot recall an instance when a member of the public ever has, and we've done this every year. So the report's pretty standardized. It talks about our efforts to reduce stormwater pollution and our efforts to remove debris and those kinds of things.
Yeah, I had read this and don't have any comments.
Yeah, I don't have any comments either. So should I just open it to
You
public?
should just ask if there are any public comments.
Okay, any public comments? Seeing no public, we'll go ahead, close it. All right.
And we'll get it filed.
Okay, so don't have any comments. All right, so we'll move on to the update on water and wastewater plans.
Yeah, so this it's too bad Tina couldn't make it because our goal was to kind of update the committee on a number of projects that we have placed in this year's budget. These are kind of planning tools and so in our current year 2022-23 fiscal year budget, we've got funds in water and wastewater for some mapping updates that labeled Water Atlas. Those are really just ensuring that the district's infrastructure is properly located, pulled into the maps from new development, and now they're going to be updated on GIS through our consultant, through Michael Nunley and Associates. So that's one component of both the water and wastewater fund. Then you likely recall we had funding for a urban water management plan in the water fund, and then funding in water and wastewater for a master plan update. So what Tina's report attempts to do is talk about the order of these items that we're going to tackle. And the long and the short of it is, we have there's some value in doing a component of what we would have traditionally called a master plan item first before we do the urban water management plan, and that is the water system model. And the reason that this is important is because at least Tina and I have some concerns that the model wasn't fully fleshed out a decade ago and resulted in some findings that may or may not be factual, or result in some recommendations that may or may not be needed. So one of the things that we want to ensure happens through this process is that we use the same data for the urban water management plan and the water system management or master plan. Urban water management plan and water system master plan. So there's no conflicts with that data. So what we're going to do is the water system model update, and then release an RFP for the urban water management plan. And after that's underway, release an RFP for the water and wastewater master plan update. We need the reason we want to do the urban water management plan first is because we feel very confident that we're going to be under an obligation here within the next, as soon as the meters are installed or those accounts go live on the Peterson Ranch, the Templeton Place 2 apartment complex at senior housing on Templeton, Peterson Ranch Road.
So that's going to throw us over 3,000.
Yes. So, and that's imminent. I mean, those are readying for occupancy and will happen soon. So once that happens, we have 1 year to become compliant. There's some other advantages too. There's some new laws that are taking effect next July for water systems that are under 3,000. So by just doing the urban water management plan once, we can be fully compliant before those laws take effect.
But you say you're gonna want to look at the water plan first.
Just the water model. That's
Water model.
That's a
How
model.
long does that take?
Well, we think that's really we've already started that work with Michael Nunley. That's really a computer model that predicts the flow demands at various points in town based on pressures and water pipeline sizes and those kind of things, and predicts the the long-term demand and what pipelines might need to be upsized. Our current capital improvement program that was part of the master plan has a number of pipelines on the west side of town being increased, like 8 inches to 12 inches and 10 inches to 12 inches and those kinds of things. And we just want to make sure before we just assume that is absolutely required, because it's very expensive,
Yeah.
that it truly is based on the best available information.
Okay. And then would that come to the board once?
It'll be part. It'll be folded into the master plan.
Oh.
it's a building block to the master
Okay,
plan.
so we don't. Okay, so all right.
But it's just running that. It's just building that model out.
So that's for you guys, so that way you have the information
So
you need.
then
to
the
move
master
on to
plan
okay.
will yes, those items then would come to the board once the master plan's in draft form. You'll see all the projects that are recommended, and we'll have a better we'll have more confidence that if a pipeline needs to be increased from 10 inches to 12 inches or 10 inches to 14, we'll know why. Because right now I can't answer that.
Okay, and then you said master plan will come. That would be done after the urban water.
At least after the urban water management plan is underway.
I think that's what she's got modeled here out on page 2, is
Yeah.
the water modeling to get to the pipes.
Yes.
And just mapping that out and verifying the size and where they're located, etc. And then it's the urban water management plan, and then the the water and wastewater master plan. It sounds like a good approach.
So yeah, and we think we've got the sufficient funding to do these items. Obviously, we'll know as we go through the process of what the costs are going to be. But one of the frustrating parts about this urban water management plan is we're going to be required to do it within 1 year of hitting 3,000, which is like in the next couple of months. And then it's going to be in 2025, just two years later, we're going to be required to update that, because once you start, you're on a 5-year cycle that all the urban water providers are on. It's the same cycle.
So the
2025,
water-
2030, 2035.
So the water modeling system, what's the kind of time frame? Because that looks like it's the urban water management plan, master plan. Is dependent upon the water system modeling.
Yeah, the modeling we think will be done this fall.
Oh, okay. So this would be fall time frame.
Yeah, we've already begun that work with.
Yeah, and these can't be done. They have to be done sequentially because there's information that is needed in the next phase.
Yes.
Okay.
All right. Well, I think this is a great roadmap.
So we wanted to outline
Yeah.
the plan for you and answer any questions and
No, I mean we got to do it. So
yeah, and like I said,
It's just one of
the
those
master
things.
planning process, a lot has changed in the decade or so since it was last updated. We now have brought on originally this plant was only treating about a third of what it's treating now, right? So, or 40%. So we now have 100% of the community. So we're just focused on growth. We have a much better sense of the kinds of constituents that are coming to the plant. Remember, this was just essentially the west side of Templeton coming here. Very different, right? We didn't have any of the restaurants or the industrial components, so that the water constituents have changed, and we really want to have a better sense of how do we utilize this facility in the long term. Where would we add additional treatment components? Where does it make sense to treat, to filter the water? Those all of those kinds of things. So, and then on the collection system side, we know we have some existing bottlenecks, like at the West Side Lift Station, where the force main isn't. It's taking all the water now, but there's a limitation to how much it can take. So, those are probably going to be kind of sort of the nearer term improvements that I could see coming out of the master plan work on the wastewater side. On the water side, we've also made a number of changes. We've increased our Nacimiento subscription. We now have a plan of how to utilize all of that in a period of time, in a more condensed period of time. We right now we have more water available to us in the winter than we could really use, because our permit, we have 500 acre foot permit that's only available from October through March, unless it can be extended into the middle of May. But so we're going to be able to utilize our water quite differently in the future, especially the Nacimiento water, where we can take all that subscription just over the peak summer season, as opposed to spreading it out year round, which we've done before.
No. That would be nice to get. I mean, so you get the full amount of the whole year and just.
Yeah, that's our plan, is to be able to take all 406 acre feet over, say, a 4 or 5 month period.
So
instead
then,
of-
what would that mean with our water buffer policy and things like that?
Well, we can control when we take it. Right now, we still can. We can control. We could. Justin could call the county, and we could have that water turned off tomorrow, and we still be able to do that. But because we're really borrowing capacity at Selby, we have to take water in smaller increments over a longer period of time, because we can't take all that water just in the summer.
I see. Okay.
Although we're taking more now than maybe ever. But under these sort of idyllic conditions, but we can't use it. Remember, we can't use it for 28 to 35 months.
Yeah.
Under the new program, we're going to be able to use it like 2 months later. So we start taking water probably like March.
That would be nice.
Yeah. So we can. It'll be a more, still not kind of real time. I mean, it's not like turning on a valve and getting the water, but much more real time than today.
Yeah.
We'd have to forecast like a problem 35 months from now to be able to adjust things today.
That's amazing.
So yeah, lots of changes in the since the last master plan was underway, a decade ago. So
Yeah. No,
I think it'll
it'd be a wise thing to look at it.
Much needed. So going back to the lift station, you mentioned the problems with the lift station, because I think I shared with both of you, a couple weeks ago when I exited Los Tablas at 10 p.m. and it smelled pretty ripe.
Yeah.
And we've had problems off and on, and I've heard, complaints about that. And I frequently drive Los Tablas and never notice anything. But that night, it was pungent. So is
think-
that going to be included in the master plan, or is that something we're going to attack much sooner?
Oh, yeah,
No,
Justin.
the
maybe-
Force meter, the odor control,
Odor
Yeah.
control, yeah.
Yeah.
That's
So-
the chemical.
We had hoped things would move swiftly after July 1st, and we've been working diligently. Our team and the Avoca team in Florida, going back and forth, and we finally arrived at language. We finally arrived at an agreement that everybody feels, everybody's ready to sign. They received, Florida, Avoca received today our agreement, and it's been back and forth and receiving input from their team through their different departments, risk management, what have you. So we're finally there where they have it, they've received it, they're reviewing it, signing it, and we'll have it here momentarily. We should have that agreement here. And then so moving into scheduling for the equipment to be installed, that just goes back to that. I believe we're going to be able to have that equipment assembled and out here faster than they were kind of giving us a worst case scenario before. We've spent so much time on this. I think we're going to be able to see that equipment out at Lift Station 3 quicker than we had anticipated
By the end
earlier.
of the year?
Yes,
Okay.
absolutely. As soon as I get updated with the agreement signed, I will get that time, that date that they're going to put us on the schedule for assembly, and get that to you.
Okay.
Get that
Yeah,
to
we'll
you,
get that
so we
information.
can be able to communicate
Yeah.
and update you.
Yeah,
we
because I
really-
think that would be good for just the community to know, to acknowledge that we're aware of it and what's being done about it, and when we anticipate it to be corrected.
Yeah, it's. I've been receiving more complaints again. You recall we put in that air filter, air scrubber, now about 2 years and 4 months ago or 5 months ago, and it was supposed to have a 3-year life. We knew it was
Yeah.
diminishing, halfway into its life, and I suspect what you're observing is just a continual reduction in effectiveness. And unfortunately, we're going to hit this. This is like the worst in my experience, my very unscientific background here. We're going to hit the worst time is going to be early mornings and late nights in October, because you still have high ambient temperatures, average temperatures, water temperatures still high, but now we're going to start getting lows like in the 30s, and so the odors just they permeate through
those
system.
and those inversion layers where you have these kind of overcast mornings, you have no place for those odors to escape.
Yeah, they just
so they just
sit.
kind of sit.
Oh, yeah.
Yeah, it's already we were hoping to beat this worst month, I'll say.
Yeah.
October's kind of always the worst month for odors, and but it took we use a standardized consultant contract or long form contract that are used, and then we offer it to the whoever we're going to work with, and oftentimes it's back and forth, and that can be resolved in just a few days. In this case, really a
gets
couple
customized.
months, because
That's
they
right.
have
It does.
requirements for
Yeah.
we have requirements for insurance
Yeah.
and workers comp insurance and indemnification and
Yeah.
all of those issues. Their attorneys won't like, and goes back and forth with our risk management team. We're a member of Risk Management Authority and those kinds of things. So we had to work those out. We had the same issues with Parkson, really, right? Kind of down to the wire to make this happen. I think those were being worked
Absolutely.
out. So.
Absolutely.
So really, I want to say the proposal was like 10 weeks or something like that from the time we signed the contract for Evoque. Was that sound right?
Yeah, the initial, I believe so. And so I'm going to be doing everything. We're going to be doing everything that we can to get them after quite a lengthy going back and forth over language. We'll be trying to put as much pressure as possible to get the equipment out here
And you may
get the chemical set up.
Remember, this is going to be. It's actually kind of. So there's a little injection that you look at. You saw the little pump that took the chemical out of the bucket and fed it a little bit. It's a bigger version of that, but same kind of thing, where we're going to be injecting this chemical. And the idea is that it prevents the water from breaking down in the pipelines and creating this odor nuisance. Right now we're trying to eliminate we're pulling the odors out of the air and trying to filter those. This concept's different. It's to prevent the odors from occurring.
And the degradation of the collections of those manholes that we just, for instance, we just lined a number of them and making sure that we get the life expectancy out of our infrastructure.
Yeah.
Absolutely.
Yeah. Good time.
So yeah,
How you doing?
we're all looking forward to that system being in place.
Okay.
Hopefully in the
Sounds
next
good.
month or so, huh?
Oh, the pressure. We'll get the
Yeah.
Yeah, so we'll keep the board up to date,
Update.
because I know
Okay.
that we're getting to the point.
Yeah.
Right? I was with somebody Friday night, and they go, "When are you guys gonna get this thing fixed?" And I was like,
Well, I think it's been
Let me
some
go-
time.
let's go
We've
over
been
here and
getting
just
these
park.
complaints
And
for
he
some
goes-
time. So I think it's, if we can have kind of exactly when do we anticipate the problem being resolved,
Yeah.
I think that will help.
Yeah.
So,
That's the hope, system-wide, from lift station 3 all the way to the treatment plant, not having those nuisance odors or the corrosion of our
That would be awesome.
Infrastructure, yeah.
So, I mean, I'm really excited. We are really excited to get finally to that point.
yeah.
All right. Okay. All right. Any other comments, questions?
No.
I'm good.
I did have one other thing. Eric ran TSS while we were, there was a few samples in the oven, and so they weighed those. So I just wanted to let you just kind of connect the dots here. So then that control station number 4, that concrete manhole.
Yeah.
So just now, so that was 54 milligrams per liter. The L pond he sampled it just in the middle of the L pond. That was 11 milligrams per liter, and the K pond was 3 milligrams per liter. So that's how
wow.
low we're running right
Yeah,
now.
that's
where
great.
you would, I mean, this is
Wow. That's huge. Going from 54 to 11 to 3.
for the study. They'd like to
That's-
see.
yeah.
They'd like to see the 54. They'd like to see the 54.
I guess it's
And
too
they
late
keep-
now. But
Yeah.
put it at the pond that was at 54.
Yeah, we could have. We could take the influent to run a longer hose.
Yeah. Maybe try that.
Yeah.
For last day, see what happens.
So that's
Yeah.
what and those are taken right at the surface. Those samples,
Wow.
those grab samples are
grab.
taken right at the surface.
So you had to set up at that pond though, at the K pond. You had no choice, huh?
Yeah, because of the
electrical issues.
and their study equipment, they're used to setting up in other types of mechanical type treatment plants that have concrete structures, and so pond systems. It was all kind of a new, first time ever, and
Yeah.
so this was the best that we could.
Yeah.
Yeah.
Probably would have been hindsight. Probably would have been better for that CS4. All right.
Well, that's hard. So if that's a surface grab, I mean, you could have, 2 feet down. That might be a different figure.
Yeah. Yeah, it's hard because we also wanted to well, it's never been this low. And then secondly, we also we wanted to this trial to really be connected. Where would we install the filter? Where would we be dealing, because control station 4 is very different than the K pond. Just the constituent levels across the board change dramatically. So it's just a shame. I can't.
So, I mean,
I don't know if it's a
is
shame.
it- I mean-
it's really good. Our treatment plant's operating. It's incredibly effective right now in treating TSS, but it's just for the study. It's very low, and so it's.
But I mean, is it possible that? So he pulled a sample from K, and it was at 3. But I mean, is it possible that what you guys been doing over the past 10 days with the, with the study, could that have had some effect on that pond as well? I mean, obviously the water is
Yes.
going in there.
But only marginally.
Well, I mean, how much? I
What
mean,
are we treating 45 gallons a minute or something right now?
Yeah, 45, 48,
so is
something like
that's
that
not enough
out
to
of the
make
350.
any difference.
No,
Well,
really.
I mean, it's
It's a-
improving. It's improving it, but I mean, is that measure?
Is
To
it-
what extent?
Yeah.
It didn't take it from 15 to 3.
yeah.
Because we're
That's-
still discharging, right? We're
We-
discharging to Selby.
Yeah, and we were on a down. We were trending down. I mean, this was week by. We're getting this data a month later, but we're getting this data and it's just trending downwards. There was a spike. There was a spike in July that we were around 80 milligrams per liter,
Whoa.
and we went all the way down to September 13th at 20 milligrams per liter. When they set up, the first day they set up, we're at 17 milligrams per liter, and it's just been a day by day kind of reduction since July. So honestly,
But
since
what
July.
do you attribute that to?
Well, we need more data, but
Yeah.
for instance, trying to elevate the pond level and set
So
it.
you think that's
and
what's
then
doing it is just
in part.
okay?
I mean, that would
Because
be
there's
nice
not,
if-
like you said, there's not a lot of levers and dials and
No, there
switches that you can adjust.
Yeah, and I can't.
So I'm wondering if we can pinpoint what is it?
Yeah,
Is
let's
it
do
just
it.
strictly
that's
the
our
level?
job. Well, that's
Yeah.
our job. That's what we're
and
committed
then
to.
if you
We
could
want to
do it
pinpoint.
without the system,
So
that
what ends up
saves
happening
$1 million.
is, even though it still feels like summer, there's like 4 hours less daylight right now than there is in June.
Certainly.
And so daylight is really the sunlight is what creates that algae, sunlight and heat.
Yeah.
So we're coming off. We're
Coming out of-
we're coming
The
out of
summer
that period.
solstice. Yeah.
Yeah.
Yeah. So
Tell me about it. Trying to take care of my pool. It's like, what's going on? Algae. It's like out of nowhere.
Yeah.
You got to be careful.
Yeah.
No, that's amazing what you're doing to have these low levels. That's
Yeah, we'll see. We'll
If you
keep
just
working
keep
on it.
yeah,
We'll keep
that-
working on it and collecting more and more data, and then
Yeah,
we'll
for-
report back how
Yeah.
yeah.
we could do
but
it.
it's always been. I mean, the seasons make a huge difference.
Yeah.
Oh yeah, yeah. Well, and if we can trend that too, that would be awesome
Absolutely.
to look at.
Absolutely.
Yeah.
We for sure. We will.
All right.
We are.
Okay. Okay.
Absolutely.
Good. I knew you would.
Yeah.
I have faith in you.
Cool.
Well, this
Well,
is
awesome.
good.
All right.
All right. Well,
Meeting
are we
adjourned?
good?
Yeah, we're
Yeah.
good. Meeting adjourned. All right. Thank